For the Now You Try problems, it's your chance to practice with the idea of graphing absolute value functions by hand. And before you continue the video, make sure you give it a try first. And I kind of laid out the coordinate plane and the table already. Think about what are the key points you want to pick in order to create a complete graph first. Whenever you're ready, you can continue the video. To complete these problems, again, I'm going to start off with finding the turning point of my graph. And in this case, if I have the absolute value function here, I still want to set whatever is inside the absolute value to be equal to 0 to find the turning point. And here I can subtract 4 on both sides to get 2/3 x is equal to -4. And to solve for x, I can multiply 3/2 on both sides of the equation to find out. And on the left, I just have x. On the right, I would have -6 because the 2's cancel out. So I get -2 times 3. And x equals -6 should be my key point, or the center point that I want to graph. And I know at that point, f of x is equal to 0. Again, next, if we want to pick the x values, I suggest looking at the denominator being 3, and that tells me if I pick multiples of 3 for the x value, I can have nice and even numbers. So I'm just working with integers instead of working with fraction operations. So these are some nice little tricks that we can do over here. And going from -6, I want to go something smaller, so let's do -9, for example. And if we do -9 here, I would have 2/3 times -9, which is -6, plus 4 will be -2. Absolute value of that will be +2. And then we can pick -12, so I just keep subtracting 3. 2/3 of -12 will be -8. -8 plus 4 will be -4. Absolute value of that will be 4 over here. When I'm completing the table, I'm doing a decent amount of hand waving or a lot of mental math over here, but if you need a little bit extra step, definitely use the space to write out the steps so everything makes sense to you, how we got these numbers over here to make sense for your own notes later on. And as we plug -3, we should have -2 plus 4, which is +2. As we expected, because we picked symmetric or points that are equal distance away from the value -6 on x, we should have symmetric values for f of x in this case, which mirrors the top part of the table. And next, for 0, we will see quickly that we have 0 plus 4, which is 4. And to scale it, we can do the same thing as before. Our x values gets pretty negative, but I think I have just enough space. Maybe. I think I need one more. And that'll be -12 over here. And then we can have 0. I'm going to label the points I will need. So this is -9, -6, -3 over here. And for the y values, it's much easier to work with. And now plotting all the points, I have these points that I'm focusing on. And lastly, 0, 4. So you can see all the points should be, again, symmetric along the axis of symmetry going through the turning point. And you can see that we will get a mirror image along this axis of symmetry for our function graph in this case. And similarly, we can do the same thing for the next problem. Whenever you're ready, you can continue on to part B. So in part B, we have the turning point coming from when negative 2x minus 5 is equal to 0. And I'm going to go ahead and add 5 on both sides. Add 2x on both sides. And therefore, I would get negative 5 is equal to 2x. And we can divide 2 on both sides and get negative 5 halves is equal to x. So with this, we are going to work with some fractions in graphing, but that's perfectly fine. Again, I would go ahead and pick some values that will be symmetric around the turning point. Here, I'm going to pick the following points over here. And I didn't go for any particular strategy in picking the points other than having 2 points that's smaller than my turning point x value and 2 that's bigger. And I still picked x equals 0 because it's easy for calculation and shows the y-intercept. And I'm going to go ahead and do some magic to complete the table for g of x over here. And here I have a complete table over, and now we are just going ahead and plotting the table on the graph. Here, when I'm scaling the graph, instead of going up by 1 for each box on my graphing paper, I'm actually going every 2 boxes being 1 because I have a fraction for my turning point. That just makes the whole process a little bit easier. And we can see negative 4, 3 is over here, negative 3, 1 be in over here, negative 5 halves and 0. So negative 5 halves is really negative 2 and a half. So it will be right over here, being the turning point. Then negative 2, 1. And lastly, 0, 5. I didn't pick exactly symmetrical points for the x values, so you will see there are some different distances over here. And when we connect the points though, the graph should still be symmetric along the vertical line that goes through the vertex, the turning point. And there it is for the graph of g of x. And check your answer to see whether everything makes sense, and make sure to note any questions you have.